Am I on? I'm on. All right, so this is going to be the unit test review, whatever you want to call it. I'm just going to go over all the problems from the test, and we're going to have a retake on Wednesday. So use this tool. Please, I beg you. All right, here we go. I'm going to go kind of fast, guys, so you can rewatch this if you need to, or slow it down, whatever. All right, so cotangent of B if cosecant is thus and secant is thus. So we have to know that the cotangent of B, or beta, is equal to cosine of beta over sine of beta, which means cosecant is that. That means sine is going to be -5 over 3 square roots of 5, which means cosine is going to be -2/3. All right, so we get -2/3 divided by -5 over 3 square roots of 5, which equals -2/3 times 3 square roots of 5 over -5, and the 3's cancel out, and the negatives cancel out. So we get 2 square roots of 5 over 5, done. Number 2. Oh man, only on number 2. I'm tired already. So we are looking for sine if we are given secant. So cosine of y is going to equal 5 square roots of 30. So let's draw a triangle. We could use Pythagorean identities, but I'm going to use a triangle. So we get 5 square roots of 30, which means we get 5 squared plus something. So we'll call it, I don't know, just x. X squared equals square root of 30 squared. 25 plus x squared equals 30. So x equals square root of 5. All right, so that means sine of y is going to equal square root of 5 over square root of 30. Be careful. Well, let's simplify this first. So we get square root of 5 square roots of 30 all over 30. Oh, man. Simplify that, baby. So we get square root of 150 all over 30. What goes into 150 that we can do is square root of 25. Square root of 6 over 30, which equals 4 square roots of 6 over 30, which equals square root of 6 over 4. Where did I make a mistake here? That's not 4, that's 5. Yeah, that's 6. And then we made a mistake. It's supposed to be negative because we have to be careful here. Tangent is less than 0. So if tangent's less than 0 and we have cosine being positive, that means sine has to be negative. Oof, it's a tricky one. So since cosine is positive, tangent's negative, that means sine must be negative. All right, so it's negative square root of 6 over 6. All right, here we go. Tangent of square root of 23 pi over 12. All right, we're gonna have to break this one down. Should we do it in radians or should we do it in degrees? Let's do it in radians. So 23 pi is equal to 7 pi over 4 plus pi over 6, because this is going to be 21 pi over 12 plus 2 pi over 12. That gives you 23 pi over 12. Nice. So we don't have to write it like that. We can write it like this. So we have to know tangent sum of angles. It's going to be the tangent of 7 pi over 4 plus tangent of pi over 6. Pi over 6 all over 1 minus tangent of 7 pi over 4 times tangent of pi over 6. All right, so changing colors here. I'm getting bored with the red. So tangent of 7 pi over 4, that is just 1, but in the fourth quadrant, so -1. Plus, ooh, yeah, you can't see green. Let's go darker green. And tangent of pi over 6 is going to be square root of 3 over 3, first quadrant, so positive. So we get 1 minus 1 times square root of 3 over 3. All right, so that gives us -1 plus square root of 3 over 3. Oy. minus 1 plus square root of 3 over 3 divided by 1 plus square root of 3 over 3. All right, can we just cancel these out and have a negative 1? Not quite. If you try factoring out negative 1, it doesn't work. So what are you going to do? What are you going to do? Oh, man. First, let's combine fractions. So we get negative 3 square root of... come on. Negative 3 plus square root of 3 over 3 all over 3 square root of 3 plus square root of 3 over 3. Does that help us? Yeah, because we get negative 3 plus square root of 3 over 3 times 3 over 3 plus square root of 3. Does that help us? Not really. Not really. Not really. Oh, yeah, it does. So boom, boom. Then we get negative 3 plus square root of 3 over 3 plus square root of 3. Whew, getting there. So now we still can't divide those out. So we're going to have to multiply by the conjugate. So that's going to be minus. That's going to be minus. And we get negative 9. Let's see here. Minus. So negative 9, positive 3 square roots of 3, plus 3 square roots of 3, minus 9. Nope, minus 3, sorry. Minus 3 all over 3 squared, 9 minus 3. Let's bring that up here. So that's going to give us negative 12 plus 6 square roots of 3 over 6. Factor 6 out. We get negative 2 plus square root of 3 over 6. Cancel. Negative 2 plus square root of 3. Now, on the test, there was a mishap. For some reason, this plus became a minus. So it's supposed to be a plus. So we're going to give you a bonus for that if you marked an answer, which I hope you did. So let's move this out of the way. Okay, cosine of negative 13 pi over 12. Let's break that into, I don't know, cosine of pi over 4 minus 4 pi over 3. Is that what it reduces to? Yeah. Because that's going to be 3 pi over 12 minus, then we get over 12 times 16. So that's going to be minus 13. There we go. So cosine of pi over 4 times cosine of 4 pi over 3 plus sine of pi over 4 times sine of 4 pi over 3. Here's the formula for difference of angles for cosine. So cosine of pi over 4, square root 2 over 2. Cosine of 4 pi over 3 is going to be negative 1/2. Square root 2 over 2. And 4 pi over 3 is negative. Because we're in the third quadrant now. Square root of 3 over 2. Which will give us negative square root of 2 over 4 plus negative square root of 6 over 4, which is going to give us negative square root of 2 minus square root of 6 over 4. This was another one there was a mistake. So this is the correct answer, but if you would have put in this, that's the same thing. So I'll give you that too. Because you can rearrange this to put negative square root of 6 plus negative square root of 2. That's the same thing as minus square root of 2. Yeah, that works. All right, next, tangent. Find the exact value of cosine 2 theta. All right, so let's get a formula for cosine 2 theta. Which one do we use? I don't know. Let's use, I don't know, cosine. Nah, let's use sine. Sine 1 minus 2 sine squared theta, which means we need sine. So let's get our triangle. So square root of 2 squared plus 5 squared equals whatever squared. That's going to give us 4 plus 20, no, 2 plus 25, 27. Yeah, so square root of 27. Square root of 27 is equal to square root of 9 times square root of 3. 3 square root of 3. All right. So if that's 3 square roots of 3, we can find our sine. So sine of theta is going to equal square root of 2 all over 3 square roots of 3, which is going to equal square root of 6 over 9. All right, now we got to determine what sign it is. It's between pi and 3 pi over 2, so it's going to be negative. There we go. Okay. So let's plug it in. Cosine of 2 theta equals 1 minus 2 square root of 6 over 9 squared. 1 minus 2 times 6 81st. 1 minus 2, blah, 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 blah. 1 minus 12 81st. 81 81st minus 12 81st equals 69 81st. And what does that reduce to? 27, nope, not 27. 23 27s. And there we go. Positive, yep, because we plugged in. Doesn't matter. We don't need to do this because it takes care of itself. So we are done. Okay, this one. All right. Find the exact value of tan of 2 theta. All right, so we need a formula. Oh, alpha. Alpha. All right. So this is going to be 2 tan alpha over 1 minus tan squared alpha. So we need tan. Triangle. 7 square roots of 2. 10 x. 2 squared plus x squared equals 10 squared. This gives us 49 times 2 plus x squared equals 100. So x squared equals 2, x equals square root of 2. There we go. So tangent's going to be opposite over adjacent, cancel, 7. Then we check the quadrant. Remember? Well, this should be A. So A is between pi over 2 and pi. So that is second quadrant. So that means this is going to be negative 7. So let's plug it back in. We get 2 times negative 7 over 1 minus negative 7 squared, which gives us negative 14 all over 1 minus 49, which is negative 14 over negative 48, which gives us positive 7/24. Yeah, positive 7/24. There we go. Next. Okay, can we do an adding sum of angles here or what? Nope, this is gonna be half angle. So we're gonna get 7 pi over 4 divided by 2. And that is our formula. So we're gonna have an equal sign plus or minus square root of 1 minus whatever that angle is here. So what is the cosine of 7 pi over 4 divided by 2? So here we go, plus or minus. Cosine of 7 pi over 4 is going to be square root of 2 over 2. What quadrant is that? That's fourth, so positive. So 1 minus square root of 2 over 2, all over 2. And let's simplify, plus or minus. Actually, we could do that right away. So plus or minus, which is it? 7 pi over 8. What quadrant is that? That is second quadrant. Sign is positive. So we're good. We don't even need to put the plus or minus every time. So we get 2 minus square root of 2 over 2 divided by 2. Come up here. So 2 minus square root of 2 over 2 times the reciprocal of 2 over 1, which is 1/2. So we get 2 minus square root of 2 over 4, which we can't simplify the top. Can't simplify the top, but we can the bottom. That becomes 2. There we go. There's our answer. Next. Oh, man. Half angle. So which one should we use? Which one should we use? Okay, 1 minus cosine over sine. Yeah, let's use that one. All right. We have cosine, we need sine. So get a triangle. Square root of 7, 4, which means we get 7 plus something squared equals 16 equals 9, 3. Easy. I like it in whole numbers. So we get sine of theta equals 3/4. Check the sign. What quadrant are we in? Between 3 and 4. So negative. Oh, how many people forgot that? Bet a lot. So we get 1 minus square root of 7 over 4 all over negative 3/4. That's going to equal 1 minus square root of 7 over 4. We got to combine fractions first. That's not going to work. So that's going to equal 4 minus square root of 7 over 4 times a negative 4/3. Oh, that's nice. So we get a negative. Hopefully you guys put your parentheses. A negative times the whole thing over 3, which is going to be a negative 4 plus square root of 7 over 3. And there we go. You could also write this as square root of 7 minus 4 over 3. Same thing, same thing. Okay, next. Rewrite the sum or difference. All right, we got to factor out the negative 18 first. And then this beast right here has rules. And you could do it using your identity sheet, so it shouldn't be too bad. Cosine of 2b. So we're going from product to sum. Plus cosine of 2b minus 6b. Gives us negative 18. Oops, got the 1/2. Don't forget the 1/2. Negative 18 times 1/2 times cosine of 8b plus cosine of negative 4b. There we go. So we get outside negative 9 times cosine of 8b. So this is an even function, so it stays the same. And then we get negative 9 cosine of 8b minus 9 cosine of 4b. Check. Okay, rewrite as a product. All right. So first thing I'll do is get that 2 out of there so we can actually do the rule. So we get sine of 4y minus sine of 10y. All right, so we're going from product to sum. So we get negative 2 times this whole thing, which is going to be cosine of them added together divided by 2 times sine subtracting them divided by 2. Right. Let's see here. Yep, so put them together, negative 4 cosine of 7y times sine of negative 3y. Okay, so this is an odd function. So remember, the sine of negative 3y equals the negative sine of 3y. So we can take that negative out and it becomes positive 4 times the sine of 3y. There we go. Done. Find the exact value of this guy. All right, same thing. Whew, my arm's tired. All right, so we're going to sum this. So we get 1/2 of sine of 5 pi over 4 plus pi over 12 plus sine of 5 pi over 4 minus pi over 12. 1/2. So we get sine of times 3, 15 pi over 12 plus pi over 12. So that's going to just be 16 pi over 12. We can simplify that a bit. And this is going to be 15 pi over 12 minus 1 pi over 12. So it's going to be 14 pi over 12. So we're going to get 1/2. That's going to be sine of 4 pi over 3. Sine of, let's see here, 7 pi over 6. That's it. And let's do it. 1/2 of sine of pi over 3. So sine of pi over 3 is going to be negative 1/2 since it's in the third quadrant, plus square root of 3 over 2. So we get 1/2 times negative 1 plus square root of 3 over 2, which gives us negative 1 plus square root of 3 over 4. Okay, you could also write that as square root of 3 minus 1 over 4. Both same thing. Find the exact value of this. Okay, same thing. We get 10, so we're going from sum to product again, times negative 2 times the whole thing, which is going to be sine of 11 pi over 12 plus 7 pi over 12, plus 7 pi over 12 divided by 2 times sine of 11 pi over 12 minus 7 pi over 12. At least we don't have to change fractions. At least we have the same denominator here. That makes it a little easier. And then we get negative 20 times sine of 18 pi over 24 times sine of 4 pi over, oops, that's supposed to be 2. 4 pi over 24. So we get negative 20 times sine of, let's reduce this, 3 pi over 6. So 4. I knew that didn't look clear. 3 pi over 4 times sine of pi over 6. So negative 20 times sine of 3 pi over 4 is pi over 2. Square root of 2 over 2, in the second quadrant, so it's positive, times pi over 6, which is 1/2, first quadrant. So we get negative 20 square roots of 2 all over 4, which is negative 5 square roots of 2. Whew! My arm is tired. All right, here we go. These are fun. More my kind of style here. So cosine of theta minus cosine of theta over sine of theta plus 1. Get a common denominator here. Multiply by sine of theta plus 1. Multiply by cosine of theta. We get sine of theta plus 1 minus cosine squared of theta all over cosine of theta times sine of theta plus 1. There we go. We can maneuver this a little bit, and we get sine of theta plus, and we know 1 minus cosine squared of theta is sine squared of theta. All right, now I see it. So we factor it out on top. We get 1 plus sine of theta. Sine of theta plus 1, cancel. Sine of theta over cosine of theta equals tan tangent of theta. Cool. That's a fun one. Next. All right. Yeah, when it's all messy like this, I would use the quotient identities, and I would get cosine of y over sine of y minus 1 over cosine of y times 1 over sine of y all over sine of y over cosine of y plus cosine of y over sine of y. All right, let's combine these now. So what are we missing here? We're missing a cosine over here, so we get cosine squared y minus 1 all over sine of y cosine of y all over sine squared of y plus cosine squared of y all over sine of y cosine of y. Nice. This is a good one. Equals cosine squared of y cosine squared of y minus 1 all over sine of y cosine of y times sine of y cosine of y all over 1. Sine squared of y plus cosine squared of y is 1. So cancel, cancel. Left with cosine squared of y minus 1. And what is that equal to? I wonder. Let's see. Let's refactor something out. We factor a negative. We get positive 1 minus cosine squared of y. And then we get a negative, and we know that is sine squared of y. Or theta. I switched to crap. I do that. So we get negative sine squared of y. There we go. Beautiful. Get out of here. All right. I would not change this to sines. I would, right away, I see this is a conjugate of each other, which means we'll probably get something out of that. So we get cosecant of x plus 1 on this side, and we get cosecant of x minus 1 on this side. All right, so we get cosecant squared x plus cosecant of x plus cosecant squared of x minus cosecant of x. Did that help us? All over cosecant squared x minus 1. All right, I think that does help us. So the bottom we know is cotangent squared of x. The top, we get 2 cosecant squared x, and these guys cancel out. All right, so maybe now we try changing it to sine. I don't know. So we get 2, 1, we get 2 over sine squared of x all over cosine squared of x over sine squared of x. Oh yeah, this is gonna work. And then that's gonna equal times, cancel, 2 times 1 over cosine squared of x, which equals 2 secant squared of x. Check. Nice. I like that one. All right. Let's do this one now. So we get cosine of b over sine of b minus sine of b over cosine of b. All this times 2 sine of b cosine of b. I just used the double angle identity. All right. Let's get the same denominator. So cosine squared b minus sine squared b all over sine of b cosine of b. And this is going to be multiplied by 2 sine of b cosine of b. So cancel. So we get 2 times cosine squared b minus sine squared b. What does that equal to? Oh man. Cosine squared b, so we have sine squared b plus cosine squared b equals 1. So where does the minus come from? You'd have to recognize this. This is cool. So this is the same thing as cosine of 2b. That's a double angle identity. Cool. So there's our answer. Nice. All right, so we need to solve for theta, and this is a negative infinity to infinity, which means we're going to have n in there somewhere. So if your answer did not have n in there, you made a mistake. So here we go. Let's see here. I would subtract secant theta, so we get negative 3 secant theta equals 2 square roots of 3. I just added this over. So I get secant of theta equals negative 2 square roots of 3 over 3. I don't know my thetas for secant, so I'm going to switch to cosine. So I get 3 over, which is equal to negative 3 square roots of 3 over 6, which is equal to negative square root of 3 over 2. Ah, that's much easier. I know those. All right, so where's theta equal to a negative? It's got to be in the second or third quadrant. So second or third quadrant would be 5 pi over 6 and 7 pi over 6. And since it's got to repeat forever, we have to have this, where n is an element of integers. All right, there's your answer. Next. Okay, let's take a look at this. Okay. I see an identity. So, what is secant squared x minus tan squared x? I hope you recognize that. We're not going from negative infinity to infinity now, so we're just going to be no n pi's here. That is 1. So, multiply by 2. We get 2 equals cosecant squared x, square root of 2 plus or minus equals cosecant x. Change that to sine. Don't mind if I do. I get sine of x equals plus or minus 1 over square root of 2, which equals plus or minus square root of 2 over 2. All right, so where does x equal plus or minus square root of 2? In the third and fourth quadrant. Okay, so x is going to be 5 pi over 4. There's our third. And 7 pi over 4. There's our fourth. And we're done. Cool. Not bad. All right, next. I don't want orange anymore. I'm tired of you. All right, this is going to be a longer one for sure. So we have to expand this. So we have to know our difference of sines and our difference of cosines. So here we go. Make sure you have parentheses or it's gonna not work. So we get sine of alpha, cosine of pi over 4. Usually we have plus when it's plus, so we're going to have minus when it's minus. So let's do it. Minus sine of pi over 4, cosine of alpha, minus, now we'll do this guy. We get cosine pi over 4, cosine A. Usually it's minus, so now we go plus. Sine of pi over 4, sine of A equals square root of 6 over 2. All right, a lot of simplifying now. So we get square root of 2 over 2, sine of A, first quadrant, so positive. Also square root of 2 over 2, cosine of A. So we're multiplying both of these by negative 1. So this is going to be a negative square root of 2 over 2, cosine of A, minus square root of 2 over 2, sine of A. All right, see if we can cancel anything out. We can. And we get a negative 2 square roots of 2 over 2, cosine of A, boink. All right, so divide cosine of A equals negative square root of 6 over 2 square roots of 2. Simplify. Negative square root of 12 over 4. Simplify. Negative 2 square roots of 3 over 4. Simplify. Negative square root of 3 over 2. Wow. Wow. No. Let's try that again. All right, so now let's solve for a. So a has to be equal to negative square root of 3 over 2. And we're in the first or second quadrant, which means we only can use the second quadrant. And the second quadrant for negative square root of 3 over 2 is 5 pi over 6. And we are done. It's a long one. All right. Here we go. All right. So we're going to have cosine of 2u times sine of u minus cosine of 2u equals 0. Factor out a cosine of 2u. We get sine of u minus 1 equals 0. Solve. You could change cosine of 2u to like 2 cosine squared of u minus 1 or 1 minus 2 sine squared of u. I'm going to do it the other way. So I'm going to do cosine of 2u equals 0, which means 2u is going to equal many things. But we got to make sure the final things are in these quadrants. So we're in second and third quadrant. So it can equal pi over 2. When cosine u can equal pi over 2, 3 pi over 2. So let's just say hypothetically we're going to infinity, 5 pi over 2, 7 pi over 2, 9 pi over 2. And then when we're finding u, we divide by 4. So it's going to be pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. Yeah, 7 pi over 4 is out of the second and third quadrant. So we know 9 pi over 4 will definitely be out. So our only two we can use are these two. That's in the first quadrant. And then for sine of u equaling 1, u could be pi over 2. So our answers, and that's in, so our answers are pi over 2, 3 pi over 4, 5 pi over 4. Okay, next. All right, we gotta square both sides to get rid of that square root here. So let's square, ooh, we don't want to square that with that over there. So we want to get that by itself. Sine of b over 2 equals 3 minus 2 cosine of b. That's much easier. If we had to distribute that, hold on, I'll show you. If we had to square that, whew, that'd be hard. Square this, multiply them both, double, and square the last. That sounds way too difficult. So let's get that over to make our life a lot easier. So, sine of b over 2, that is going to be plus or minus the square root of 1 minus cosine of b over 2. And we're going to square that. And we get 3 minus 2 cosine of b. We're going to square that. All right, so we get 16 times 1 minus cosine of b over 2 equaling 9 minus 12 cosine of b plus 4 cosine squared of b. Square the first, square the last, multiply together, and double. That's how you do it. And this becomes 8 times 1 minus cosine of b equaling this guy. Oh, I have an idea. Cool. Anyway, let's come back up here. We get 8 minus 8 cosine of b equaling 9 minus 12 cosine of b plus 4 cosine squared of b. Let's get it all equal to 0. So we get 4 cosine squared of b minus 4 cosine of b plus 1. All right, we got to factor it. Ends up giving us, I don't know. Oh, this is going to be a 2 cosine of b minus 1 squared. So get 2 cosine of b minus 1, 2 cosine of b minus 1. We only need to do 1. So cosine of b equals 1/2. Cosine of b equals 1/2. I'll do them both to show you they're the same. And let's see here. What quadrant are we in? We're in the fourth quadrant, which means going to have the same answer. B is going to be 5 pi over 3. B is going to be 5 pi over 3. So just take one of them. Don't need both. 5 pi over 3 is your answer. How many more have we got here? Whew, last one. Thank God. All right, here we go. Oh, man. My arm is cramping up. All right, so we need to first see what the heck we got to do here. All right, let's switch these to sum to product. We need it in a product. So we get 2 times sine of 4y plus 6y over 2 times cosine of 4y minus 6y over 2 plus cosine of y. So we get 2 sine of 5y times cosine of negative y plus cosine of y equals 0. So we get cosine of, remember, cosine of negative y equals cosine of y. That's an even odd identity. This one's even. So we get 2 sine of 5y cosine of y plus cosine of y equals 0. And we can factor out a cosine of y. Ooh! So we get 2 sine of 5y plus 1 equals 0. So where's cosine of y equals 0 in the first quadrant? At pi over 2. Where does sine of 5y equal negative 1/2? So where does y equal negative 1/2 in the first quadrant? Oh man. Let's just say, where does y equal negative 1/2? And then when we simplify it by dividing by 5, we'll see where it becomes in the first quadrant. So let's see here. Can't be in the first quadrant. So let's just do all the places it is negative 1/2. So where is y equal to negative 1/2? Sine of y equal to negative 1/2. We get third quadrant and fourth quadrant, which is 7 pi over 6, 11 pi over 6. Let's keep going. So if we added another 12, it'd be 19 pi over 6. And 11 pi over 6 plus another 2 pi, 23 pi over 6. All right, so now we find y. So we get 7 pi over 30, 11 pi over 30, 19 pi over 30, 23 pi over 30, and we see which one of these are in the first quadrant. This is not. This is not. This is. This is. So those are the two we use. So our answers are pi over 2, first quadrant, 7 pi over 30, and 11 pi over 30. There we go. And we're done. If you have any questions, guys, just